Hello, this is Mr. Waters, and I'm going to do here another example for the homework, and this is from page 678, and it's going to be about graphing the curve whose parametric equations are given. There we go. And then we're going to find the equivalent rectangular equation of the curve, and we're going to do a couple of these and see how that goes. All right, now, so let's see. I'm going to scroll down a little bit here. And I'm going to move this over here a little bit, just like that. So let's say that we've got this parametric equation right here. Let's say that x is equal to the square root of 2t, and let's say that y is going to be equal to 4t, and on our parametric equations, we always have an interval stated for the t, and for our parametric equations here, the t is greater than or equal to 0. Now remember, what we mean by a parametric equation is a function, a rectangular function really, whose ordered pair is x and y, like that, and we're going to graph it on the xy plane here, as you're going to see in a minute. But instead of having an equation that's for y in terms of x or for x in terms of y, the two variables x and y are each given a separate rule in terms of a third variable t. In this case we're calling it t, which is called the parameter. And so the values of x and y are determined in terms of how much independently and separately in terms of what this parameter here, and that should be an a there. Okay. All right, so anyway, so what do we do to graph it? Well, the simplest or the most simple-minded way to go about doing this would simply be to make a t-table. Okay. You go down and make this here, just like that. And it's going to be a 3-column t-table. Okay, the first column has the actual values of the parameter t. This is going to be x, which is equal to 2t, rad 2t. And then this is going to be the y column here, which is 4t. Okay, so we pick, like with any other t-table, we pick some appropriate values for the t, for the input variable. And we'll start at the end, at the beginning of the interval, which is 0, to give an idea of where we should start. And then let's pick some other ones. And I'm going to pick ones that, since we're going to be taking a radical here with the x, ones that if we multiply it by 2 will give us a nice easy square root. So I'm going to go with 2 here for t. And I'm going to go with, I think, 8 for t. Okay, so start out with this one. So the square root of 2 times 0 is equal to 0, and 4 times 0 is equal to 0. So one ordered pair that's on our function is going to be 0, 0. Okay, now the second value for t is 2, so we put that in. The square root of 2 times 2, which is square root of 4, which of course equals to 2. Over here, 4 times 2 is 8. So x is 2 and y is 8, and so the ordered pair 2, 8 is in the function. All right, and then the last one here is we put 2 times 8 square root. 2 times 8 is 16. Square root of 16 is 4. Then over here, 4 times 8, which of course is 32. So 4, 32 is in the function. Now we're going to go ahead and graph that. Okay, so 0, 0 is the first ordered pair, over 2 up, 1, 2, 3, 4, 5, 6, 7, 8. And then 4, 32, 1, 2, 3, 4, and 32 of course is way up above our graph, so I'm just going to kind of put that up there like that. And this is the, see, it's a little sloppy. Going up like, going up like that. There we go. Make that one bigger. So there we go. There's the graph of our function, which is pretty sloppy. You see, the graph does not exist on the negative or the left side of our xy axis of the Cartesian plane because t starts at 0. All right, now we're going to go ahead and we're going to make a turn this into a create or figure out what the rectangular version of this is. And so we're going to go over up here to x is square root of t, y is 4t. We want to solve the x one for t. So I'm going to go ahead and I'm going to square both sides, and I'm going to, actually I'll write this down here. X is equal to rad 2t. I'm going to go ahead and square both sides to release the 2t from the radical. Cancels out the radical. So 2t is equal to x squared. Divide both sides by 2. T is equal to x squared over 2, or 1/2 x squared. Now we put this now, this t here is equal to that t there, so we substitute this chunk right where that t is. So y is equal to 4 times 1/2 x squared. 4 times 1/2 is 2. So y equals 2x squared is the equation of our function here. And you can see that our ordered pairs, these guys here, in the shape of our graph, although I was pretty sloppy with it, we can see that this looks a lot like the right side of a parabola, and that's really not helping, is it? Okay, anyway, so that's the first example right there. Now let me do another example that's a little bit different. I'm going to scroll down. Okay. Get us some more room. There we go. And this one is going to look like this. The parametric equations are going to be x is equal to 3 cosine theta, or not theta, sorry, 3 cosine t. Theta could stand for the parameter, but I think that'd be a little confusing because we usually use that for angles. Y will be equal to 4 sine t. Now, before we, in order to graph this one, we're going to actually create the rectangular function first. We could go ahead and make a t-table and get values for t, but it's easier to graph, and you'll see why when we've actually turned this one and found the equivalent rectangular function. Now for this one, we're going to say that the interval for t, I'll write it right here, the t interval will be 0 up to 2 pi. And you know, in order to cover that entire interval, we're going to have to create probably or evaluate quite a number of examples to really see quite a number of points in ordered pairs to see what it looks like. And it's actually probably going to be easier for us to graph using the rectangular function. Okay, so we're going to go ahead and change these and turn this into its equivalent xy rectangular function. Now, normally we could do like the earlier ones and solve for t, but solving for t would involve arc cosines and arc sines and all kinds of messy stuff. It's simpler if we just recall this Pythagorean identity from back in days of trig. Cosine squared plus sine squared is equal to 1, or written a slightly different way, cosine of t, quantity squared, plus sine of t, quantity squared is equal to 1. So let's go ahead and look at our parametric equations. We've got x is equal to 3 cosine t, and then y is equal to 4 sine t. What we'll do is instead of solving just all the way for t, we'll just solve for cosine t. So I'm going to divide by 3, and get cosine t is equal to x over 3. And then this one, divide everything by both sides by 4, so that sine of t is equal to y over 4. Now, we go back and we look at our identity. Okay, you can see that's cosine squared, that's sine squared, that's cosine t squared, that's sine t squared. Well, gosh, cosine t is equal to x over 3, and sine t is equal to y over 4. So we can go ahead and substitute those into the identity equation, the Pythagorean identity, this guy right here. I'm going to put the x over 3 where the cosine is. I'm going to put the y over 4 where the sine is. Okay, so that's going to give us x over 3 quantity squared plus y over 4 quantity squared is equal to 1. Now we actually simplify the square and we get x squared over 9 plus y squared over to 16 is equal to 1. And there's our rectangular equation with just x's and y's. We can see, it's pretty clear, that that is the equation of an ellipse whose center is at 0, 0, and which is vertically oriented because the larger of the denominator values is under the y squared. And in the ellipse, that's always the larger denominator value is always a squared. So that's good. So what we've got there, you see, is an ellipse centered at the origin, vertically oriented. So makes our axes there. Okay, the a squared is always the bigger one. So a squared is equal to 16. So a is equal to 4. That's the major axis. B squared is equal to 9. So b is equal to 3. So that's the minor axis, b3, or b is equal to 3. So we go over here to our graph. There's the center at 0, 0. We go up 1, 2, 3, 4. Down 1, 2, 3, 4. And then b is equal to 3. So 1, 2, 3. 1, 2, 3. And there is our graph right there of the parametric equations. Anyway, so I think that's all we need for these, and there's a couple of examples for how to do the parametric equations. And anyway, thanks for listening.